Hello everyone, my name's Pintang Arigo, and in this video I will talk about memory management. So let's get right into it. Generally, for memory management there are a few algorithm types, which are contiguous memory allocation, and the second one is non-contiguous memory allocation. So first I will talk about contiguous memory allocation. Contiguous memory allocation is a classical memory allocation model that assigns a process consecutive memory blocks, that is, memory blocks having consecutive addresses. So this type of algorithm for memory management has two types of partitioning, which are fixed size partition and variable size partitions. So fixed size partitions, the main memory is divided into a number of static partitions at a system generation time. A process may be loaded into a partition of equal or greater size. So this type of partition generally suffers from internal fragmentation, which is fixed partitions suffer from inefficient memory use, which is any process, no matter how small, occupies an entire partition. This waste is generally called internal fragmentation. Unequal size partitions are better in terms of internal fragmentation, is also important to note. And move on to the second type of partitioning, which is variable size partitions. This type of partition is of variable length and number, and each process is allocated a contiguous memory block of exactly the size it requires, so no internal fragmentation. The termination of a process releases its memory block. This type of partitioning suffers from external fragmentation. So the main memory eventually forms holes too small to hold any process, and the total memory space may exist to satisfy a request, but it is not contiguous. And we can use compaction to reduce external fragmentation by shuffling memory contents to place all free memory together in one large block. So moving on, there are a few possible allocation algorithms for contiguous memory allocation. The first one is best fit, which allocates the smallest hole that fits, and the second one is worst fit, which allocates the largest hole, and the third one is first fit, which allocates the first hole that fits from the beginning, and the last one is next fit, which allocates the first hole that fits from the last placement. So to simulate the memory management processes, we will use a software called OS Simulator, and we can check the examples by going on to help and then going to examples and then memory management. And then the first one we will simulate is contiguous memory management with fixed size partitions with first adjustment, which is first fit. So as you can see, the this block here represents the operating system, and the empty or white blocks currently represent the unpartitioned memory, and these are the processes. So let's go ahead and play it. So as you can see, the simulation has finished for this particular fixed size partitioning. So these are the processes, and these dotted blocks are the internal fragmentations. So moving on to the other type of fit, which is best fit. So it's generally the same. So let's go ahead and run it. So as you can see, the simulation is finished and the internal frag is located after the process. And now we'll move on to another example of memory management. And we'll try worst fit. So as you can see, this has the most amount of internal fragmentation because it is the worst possible fit for the partition memory. And next we will simulate the contiguous memory management with variable size partition with defragmentation. So this is the simulation for contiguous memory management for the variable size partitioning. Unlike the fixed size partitioning, it suffers from external fragmentation. As you can see here, the dotted block here. So let's go ahead and run the simulation. So as you can see, there are external fragmentations that are present in this type of partitioning. And we'll move on to the next example, which is contiguous memory management with variable size partition, but with swap. And similar to the one before, it also has external fragmentation since it is variable size partitioning. And let's go ahead and run it. So as you can see, the external fragmentation is present at the bottom. Before we move on, I'll also show the other types of fit. So before we saw first fit, now let's try best fit. And let's go ahead and run that. So for this one, we can also see that there are a few external fragmentation. And now we are going to try for worst fit. So as you can see, this also has a few external fragmentation. So moving back to the slides, we'll move on to the next type of memory management, which is non-contiguous memory allocation. And this type consists of two type of memory allocation, which are first pagination and the second one is segmentation. So first I'll explain about pagination, which the memory and processes are divided into equal sized parts in frames and pages, and the process pages are generally allocated into available memory frames. And the second one, segmentation, which processes are divided into logical parts like code, data, or stack, and they are allocated separately into memory partitions of its size. So moving back to the OS simulator, I will show you an example of pagination and segmentation. So similarly as before, this block represents the operating system, and these are the processes, and the empty blocks are the unpartitioned memory. So let's go ahead and run it. So as you can see, the process has finished, and as you can see, there are some internal fragmentations here, and at the bottom here. And we'll move on to segmentation. So for segmentation, you can see that there is external fragmentation. So let's go ahead and run it. Okay, so the simulation has finished, and as you can see, there is a little bit of external fragmentation at the bottom. And I think that's pretty much it for memory management. I hope you enjoyed my video, and I'll see you on the next one.